This is part 4 of the chemical changes topic in GCSE AQA chemistry. It is a dual and triple award topic, so all students taking AQA chemistry will need to be able to do this. In this video, we are going to focus on bond energy calculations. It follows on from the theory in the previous video that looked at reaction profile diagrams, and we're going to look at energy profile diagrams once again as part of these calculations. Now, in these calculations, you will be provided with bond enthalpy data. And we can see here that there is a set amount. For a carbon-carbon single bond, the bond energy is 347 kilojoules per mole, for example. Now, we have got to remember something very important here, and it follows on from the previous video. If I'm breaking that bond, it's an endothermic process. Endothermic is positive. So the energy change for breaking a CC single bond would be plus 347 kilojoules per mole. But if we form that bond, that's an exothermic process. So it's the same magnitude, but this time it would be negative. So that's minus 347 kilojoules per mole. So let's look at how we might go through this. Very often you will be provided with what the bonds actually are, but we'll see some more complicated ones as well. The overall energy change is going to be the sum of the amount of energy needed to break every single bond in the reactants. And we're going to add to that the negative value for all of the bonds that were formed. It's potentially easier to see that in practice, so let's look at an example. If I take H2 and Cl2, I make 2 moles of HCl. So I'm breaking one HH bond, which I can see here, and from the table I can see that has an energy change of 436 kilojoules per mole. With chlorine, I am breaking one Cl-Cl bond, and that's 243 kilojoules per mole. I've put the signs in because I'm reinforcing the idea that breaking bonds is endothermic, which is positive. So the total energy to break the bonds in all of the reactants is the sum of those two numbers, plus 679. Now, if we then look at what's happening on the other side of this, we think about the bonds we're making, and we're making 2 HCl bonds. So HCl has a bond energy of 432 kilojoules per mole. This is forming the bond, so it's exothermic, so it's negative, and there are 2 moles. So 2 times negative 432 gives us negative 846 kilojoules per mole. So I needed 679, but I've released 846. The overall enthalpy change is the sum of plus 679 and negative 846, giving us an overall energy change of negative 167 kilojoules per mole. Because it's negative, that tells us the overall reaction is exothermic. Now there's a chance for you to have a go at a few of these questions again. See how you do. So in the first example, we're breaking one N triple bond N, which is 945 kilojoules per mole, and we're breaking 3 HH bonds, which is 3 times 436. The sum of all of those bonds breaking is plus 2253. But we're forming, and be very careful with the multiplying up, we're forming 2 ammonias, 2 NH3s, that's 6 NH bonds. NH has a bond energy of 391, but we're forming, which is exothermic, so it's 6 times negative 391. We multiply those up and we get negative 2346. Now, the overall is going to be the sum of 2253 and negative 2346, which comes to negative 93 kilojoules per mole. Let's also illustrate this with an energy profile diagram. If I draw what we saw in the previous video, it's exothermic, so the products have less energy than the reactants. We know that because the overall energy change is negative. And then I can start to put the data in. I needed 2253 kilojoules per mole to break all of the bonds in the reactants. And I released 2346 when I made all of the bonds in the products. And therefore, the overall change is from reactants to products. And there is our negative 93. Another one for you to have a go at. And on here, we are breaking two HH bonds. We've got the value 436. So 2 times 436 is plus 872. We're also breaking one O double bond O, 498. Add those together. My total energy to break all of those bonds is 1370. Then let's have a look at the bonds that we're forming. It's 4 OH bonds. So that's 4 times negative 464 we're making, so it's exothermic, so it's negative, that's negative 1856. And our overall energy change is the sum of plus 1370 and negative 1856. That takes us to an overall energy change of negative 486 kilojoules per mole. Let's once again put that into a reaction profile diagram. It's exothermic, so my products have less energy than the reactants. It has the activation energy. I needed to put energy in for the reaction to go ahead. I put my values in, plus 1370, negative 1856, and we can see the overall difference is negative 486. Let's look at another example. So on this one, we're breaking 4 CH bonds. That's 4 times 413. Which is plus 1652. We're breaking 4 ClCl bonds. We've got the 4 Cl2 here. That comes to 972 in total. 4 times 243. And in total, that means 2,624 kilojoules per mole to break all of the bonds. Now let's look at the formed. We're making 4 CCl bonds and we're making 4 HCl bonds. So we've multiplied up the numbers here and then we add together both of these, and that comes to negative 3112. My overall energy change is the sum of these two numbers. Plus 2624, take away 3112, and that takes us to negative 488 kilojoules per mole. And once again, let's take a look at the profile diagram to try to link all of this together. It's exothermic overall once again. I've got my plus 2624 to break all of the bonds in the reactants. It's negative 3112 when I make all of the bonds in the products. And the overall change is, there's my negative 488, and there it is again in diagram form. That takes us to the end of this video. Thank you for listening and goodbye.